Welcome all to my presentation about the topic of assessing nature of science in the Earth Study program called Juniorstudium of my university in Rostock, that is northern Germany. So, very cool. Before I start, I'd like to introduce to you the German school system. There are two tracks I would like to highlight. There's the lower secondary level and the upper secondary level, where students going to get their A levels and then can go into higher education. And German code is issued of federal states. So there are 16 different curricula, and it's quite difficult to speak for the whole Germany. Yeah, that I would like to highlight. And I'm going to speak about the red right there, focusing on upper secondary track. So I start with the personal anecdote, because when I started studying, I went from a little village to University of Rostock, and two friends of mine were sitting in the introductory lecture. 1 year later, they dropped out. So I went on the statistical bright side, and that is quite the problem we're facing in Germany. We have actually very high student dropout rates, and especially for the science and mathematical field, dropout rates are obviously at 50%, and that is far above average. So the universities had to react to it somehow, and they did so-called crash courses. 2 or 3 weeks to get to know the content and knowledge, but you can catch up in 1 month what you didn't do in 2 years. So maybe a new perspective could be the Juniorstudium, which was founded in mid-2000s, early on oriented for gifted pupils, but lately it has been reorganized and opened to all upper secondary students. And the registration is free, and for example, last winter semester we had 400 to 500 registration participants. 40% of them are from my federal state, 60% are widespread about Germany. So what did we do? We recorded introductory lectures of real professors and give it to the junior students. The goal is quite clear, giving them first insights, study orientation, and if they have so, this study choice review. So therefore we have authentic lectures with real professors, their behavior, their speech, their habits. We students as tutors, which are moderating the courses, and they give them actual tasks from the study. So for example, I was a tutor myself for experimental physics, and I took the homework of my first semester, give it to the junior students, and for the semester task at the end, I invited them to our university, and we did the frontward experiment. They had to write a protocol, and that was the semester. So that's the structure of the Juniorstudium. But what could that benefit? Maybe it is scientific literacy in some way. So there's this construct of Roberts in 2007 describes scientific literacy as a continuum between two polarized poles. Lately, there has been efforts towards Vision 3, science for transformation, but anyway, I honestly have to say that with the Juniorstudium, we're gonna promote epistemological aspects, so it is oriented in the pattern sense. I would love to say we're gonna promote science for all, science for transformation, but yeah, you know, first introductory lectures, and it's quite difficult. All right, so when I'm talking about epistemological aspects, I'm referring to the topic of nature of science and inquiry. And the construct is actually about how science functions. It's a meta-reflective construct about the science. It is, of course, there's multitudes of constructs, and also a dominant approach, I would say, the consensus framework of Biedermann colleagues, which have 10 or 7 to 10 aspects. You see it on the right. Creativity is there. So epistemological aspects. I'm doing my PhD right now, and when you are in this research, I would call it the differentiated rabbit hole, you unavoidably stumble about the concept of epistemological beliefs, which is a discourse, which is very wide, not consensual at all. But when I look at recent constructs, they all refer in one or another way to the work of Hofer and Pintrich. And you see it on the right, they described two major categories and 4 dimensions in it. So epistemological beliefs, this is somehow consensual, are general and are also domain specific. And nature of science as a construct, and that's my assumption, is somehow the domain specific answer to epistemological beliefs. Methodological conclusions later on. First, I would like to show you some empirical findings towards the nature of science inquiry. So in Germany, we're having at most mixed understanding in upper secondary school track, and also underrepresentation of these aspects in our textbooks and also curricula. And teachers also having mixed understanding, for some aspects naive, some are quite good. But all in all, we have to say the environment in the upper secondary school track to learn about nature science is quite limited. And why should they learn actually nature science or epistemological beliefs? That is due to the fact that there are many positive correlations between sophisticated views of epistemological aspects and learning-related constructs. You see some of them on the slide. This will be beneficial for performance challenges at academic level. For the introductory phase where the stuff student dropout is quite. So, come to my research question. First of all, the method. I show you now my my work on the instruments. So, in Germany, there's a we call it famous questionnaire from Kramer, widely used, and it came from an explorative factor analysis from many items of many questionnaires relating to nature of science and also relating to epistemological beliefs. 7 scales and 44 items. And I investigated it through the lens of epistemological beliefs, and I rearranged the items. So that on the right you see my scales from the new questionnaire. Because of redundance of some items, I had to add some items from the questionnaire to assess epistemological beliefs of Moshe and Gruber into the scale of the source. So all in all, there are 42 items in 5 scales, and I'm assessing it with the 5 conjugate scales due to the fact that it has to be somehow economical for 400 participants. So I did that one way for the sample of upper secondary students. And I have another sample that is the first cohort of our winter semester. On the right side, you see the whole sample, 450 participants, but only 95 took place in our survey. That is not so good responsibility, I would say, but we're working on it. We changed our online platform. All right, coming to the reliability. I use the Kronos alpha coefficient to show it, and at first look, we have to say that the reliability is not good at all. Yeah, but for assessing epistemological beliefs, Musil pointed out that the Kronos alpha should be reduced to cut off at 0.5. That is so because we are assessing quantitative self-reported informations, which are somehow unconscious or unaffected. And for that, we have to say all scales are, if we take this assumption into account, is all okay. Okay, go forward to my second research question. The question of Prima was used for the lower secondary level, and she showed that with an increasing grade level, the nature science understanding also increases. So it is quite unclear whether this progresses also in upper secondary level. And therefore, I used the sample of the upper secondary students. I did a crystal waters test to look whether there are increases. And you see on the right, 4 out of 5 scales are significant. So we could say that, with increasing level, the nature science understanding also improves in upper secondary school. I would like to highlight that the source mean scores are also somewhat increasing. Maybe we should do some more research. The sample size to get a little bit higher. All right, coming to my third research question, whether junior students and upper secondary students possess different understandings. I started with a calculation, just doing a manual U test. You see 2 skills are significant, so the junior students possess in 2 skills better understanding. But if we take our findings from the research question 2 into account, we should compare it grade-wise. And I did that, quite a big table. For the 10th grade, you see that there are 3 significant differences and no differences for 11th and 12th grade. But I would like to highlight that there are some statistical limitations. First of all, the sample size for each grade is very low, so more research needs to be done. And secondly, I would like to highlight that the date of the assessment is very important because the junior students, we assess them in September, start of the school year, and the upper secondary students assessed in May. So if we take research question 2 into account, it might be helpful to set it up new. But maybe there are first hints that there are no differences if you're going further, so it might be a level above. All right. All in all, summarized, the new instrument is reliable for the assumption that we are assessing epistemological beliefs. We see an increasing understanding of nature of science for the grade levels rising, and there are first in that there are no differences in higher grades, but 10th graders show really some differences. So what needs to be done furthermore? My PhD thesis, the main question is whether the junior student has effects to improve nature of science understanding. And therefore, a pre-post design is required. The winter semester data is there, but it is not so good. I only prepare 32 from 415, so that is less than 10%. That is really a problem. And it would also be interesting to look at longitudinal effects of participation in the Juniorstudium due to the problem of student. I would like to give you a vision at the end. So the early study program could be an anchor part of the curriculum. Maybe those students who want to study later and they know it in 10th or 11th grade, we should give them the opportunity to get a first look into academic. That would be nice, in my opinion. And secondly, maybe we can work on a network of junior students because we are only recording Rostock, I would say, University of Rostock, only the lectures from there. Maybe it would be cool to record also some biological courses of Munich, some of Cologne or Berlin, and that we have widespread and also more capacity because our project is restricted to financial. And the student tutor can only take 30 to 50 students per account. So there are limitations to the size. And maybe that will be a new perspective for the upper secondary level, that we are more based on interest. I would like to thank you for your attention. And, yeah.